Today, guys, we are looking at adding and subtracting radical expressions. You've already read this paragraph here. It says the radicand and the index must match exactly. If the radicands do not match, simplify the radical first. Add or subtract the integer in front of the radical to simplify. So, for instance, the very first one, remember that the radicand is the number on the inside. Do these two match exactly?
Yes.
Yeah, they do. On the index, both of these indices are 2. We're just talking about 2 and 2. Thank you very much. So, since they're both square roots, we're fine. They're both the same thing. So, if we have 3 of these, and we have 7 of these, how many do we have total? 10. 10 what? 10 square root of 5. Okay? Okay? Number 2. Are these two the same thing? Yeah. So all we do is we say 6 minus 4 is 2, so we have 2 square root 2. I would like you guys to do 3, 4, 5, and 6. 3, 4, 5, and 6 on your own. 3, 4, 5, and 6. 3, 4, 5, and 6. Three, 4, 5, and 6 on your own. You're taking care of business. Probably don't need a whole lot more time like this. So if we have square root of 7, square root of 7, it's the same thing. So all of a sudden I just say 18 minus 26 is negative 8 square root of 7. How many people have that for number 3? Raise your hands. Nice work. Awesome. We have square root of 5 and square root of 5. There's technically like a understood that there's one of those and one of those. So if we were to add them together, we'd have 2 square root of 5. Tyler, do you have a question?
Yes.
Okay. What's your question? I'm sorry. Number 2. What's going on now?
No one.
Yeah, you say 6 minus 4 is a positive 2. 6 minus 4 is 2. Okay, for number 5, you say 4 plus 1 is 5. 5 what? 5 square root of 3. And over here, there's basically an understood 1 here. So we basically have 1 minus 7 is negative 6 square root of 13. How many people got at least 5 of those 6 correct? Awesome. Questions on the first 6? Please.
Okay, so does the inside?
The radicand.
Yeah, the radicand is just
Wait, hold on. You guys need to be silent and respectful so that he can ask this question. He wants to learn. He's taking the initiative in class, which takes a little bit of work to ask questions in class. Please let him ask this question. You might be thinking the same thing.
Okay, does the radicand just stay the same always?
Okay. Well, here's the question. It does say up here, the radicand and the index must match. They must match exactly in order to do this. So the idea is, in algebra, if you have a 2x and you have a 2x squared, are those two the same? They're not the same. X and x squared are not the same. You can't combine them. Okay? 2x and a 2x squared, they don't have the same value for x there, so you can't add them together. If your radicands are not the same, like if you have a square root of 2 and a square root of 22, you can't add them together. Okay? They need to be exactly the same in order to do this. So number 7, can we add them together? No. Not in the way they are right now. Okay? So let's take a look at this. Can you break down 50 in any way?
Yes.
2 and 25.
Okay. We could say 2 and 25. And then we could say 5 and 5. This could be rewritten then as the square root of 5 minus, since there's a pair of 5s, it would be 5 times the square root of 2. Now, can I add these together?
No.
No. This radicand is 5, this radicand is 2. You cannot add them together. So this is your final answer. That's where it is. That is fully simplified. That's as far as you can go. So to answer his question, you can't always add them together, but you need to know when you can and when you can't. Okay?
Wait, I don't understand the. Okay, so I Okay, I know the square root of 5 minus.
There was a pair of 5s.
Yeah, where'd you get the 2? Just the leftover?
And that's the leftover part. Okay. Number 8. Hope that. Tie. Tie. Not Tyler. Tie. Right, how do we break down 27? Remember, you're going to have to use it without your calculator, so maybe you want to get in the practice of doing this now, Tyler. Or Ty. 3 and 9. How do we break down 9? 3 and 3. Okay, so how can we rewrite square root of 27? Okay. You can't say to the, because that means it's in an exponent. Okay. You could say 3 times the square root of 3. It's fine. I just want to make sure that you don't say that because that means an exponent. That would be 3 to the square. It would look like that, which is really a mess. We don't want to do that. Okay. What about 75? How do we break that down?
25 divided by 3.
Okay, so that's 3 and 25. How do you break 25 down? 5 times 5. What do we get here?
5 times square root of 3.
Very well said. Are the radicands the same?
Yes.
Yes, they are. They're both 3. So, we have 3 square root of 3s and 5 square root of 3s. How many square root of 3s do we have?
8.
Okay, you just add 3 and 5 together. You're adding them together. So you have 8 square root of 3. Tyler Mancuso, number 9. Well, you have a 3 and 2. Sure, got it. You have a pair of 2s. I'm just going to take these 2 right here. So that'd be 6 times 2 times what's left over? There's a 3 and a 2 left over here. So that'll simplify all the way down to 12 times the square root of 6. Okay, that sounds good to me. Is that okay with everybody? Yeah, apparently it's not. What's your question?
I did.
Yes, you can break them down differently. You should always get the same answer. Got it?
Yeah, but could you break down 48 to 24?
We haven't done that yet.
Is that what we're doing?
That's what Tyler's going to do next. Tyler, take it away. How do we do 48? 12 and 4. 4 is 12 or 2 and 2. Got it. What's 12? 6 and 2. What's 6? 3 and 2. Got it. Okay. Are there any pairs? There's 2 2s. And then another set of 2s. So that'd be plus 32 times 2. What's left over? There's just a 3 left over. So this would give you plus 4 square root of 3. Can you add those together, Tyler? No, because the radicands are different. One's a 6, one's a 3. So just leave it like that. In the order that it gave it to you, just leave it like that. Okay? So leave it in the order that it had. Does anyone have any questions over this at all? Okay. So each of these do need to be in the most simplified form. So that they do need to be fully simplified. Nicole, number 10.
Okay. 11 times 4.
11 times 4.
And then 2 times 2.
2 times 2. Are there any pairs?
Yeah, pair of 2, so it would be 2 times square root of 44. I mean 11.
Of 11. Sounds perfect. What about 99?
11 times 9. And 3 times 4. 3 times square root of 11.
Do they have the same radicand? They do. So what do we do? Can we subtract?
Oh, 1 to square root.
So it's 2 minus 3 is
Or
negative 1.
sorry.
So instead of writing negative 1 times the square root of 11, all it is we say negative square root of 11. Okay? You should not write that 1 there, because when you multiply it, you don't need to multiply anything by 1.
On a test.
It's not fully simplified. You do not need a 1 there.
So what if you do it on a test? What if you count it wrong?
It's not fully simplified, so yes, I would mark it wrong. I'd take off 1 point. Okay? You need to make sure that you simplify it all the way. Leaving a 1 in there is not fully simplified. Okay? Why don't you guys try 11 and 12 on your own? Try 11 and 12 on your own. They are larger numbers. And honestly, you should get used to that because we're going to have a test. It's going to be on Tuesday. It's going to be on orange paper. Got to get used to bigger numbers. And if you need to, just divide things by 2 if you need to. Okay? You guys try 11 and 12 on your own. I'm going to do it on my own. Don't wait for me to do it. I appreciate you guys working hard on this stuff. This is a little tough. It's a little challenging. Okay, let's walk through these 2 problems. Number 11, I broke my 98 down to 49 2 because 49 is a perfect square, which is 7 and 7. So I could say 4 times the 7, which is on the inside. So there's a pair of them. I should pull it out. 4 times 7 is 28. Remainder of 2 here. Next, 32 can be broken down to 16 and 2. 16 is 4 and 4 is a perfect square, so I say 4 times 6 is 24 times the square of 2. 28 and 24 make a total of 52 if I can add correctly in my head times the square of 2. Okay, the next one's a little more complicated because 208 is a big number. Okay, both 208 and 52 are both divisible by 13. That's what I did first. Divided by 13, you get 4 and 16, which are both perfect squares. I was able to pull those out. So 15 times 4, which gives you a 60. There's just a 2 on the outside. So 60 minus 2 gives you a total of 58. 58 times the square root of 13. And again, there are several different ways you could do that. You could break things down and say, well, I don't know, like 26 and 2. You could say, there's a lot of different ways to break those numbers down. In the end, no matter how you break it down, as long as you break it down legitimately, you're going to get the same answer. Okay? You can break it down any way you want as long as you get the right answer. Questions on these 2? Yeah.
Can you explain to me, because I don't understand, like, for 11, how do you know, like, it's 4 times 7? Because I thought it was, like, 7 to the square root of 2. Just how do you know when to like
So,
times seven?
since there's a, you ask yourself, are there any pairs? The pair is what you take out. So there's a pair of sevens, that's what we take out. And whatever's left over is what goes inside.
I know, but then why use 4 times 7?
Oh, because there was a 4 on the outside originally, and then there's the pair of sevens, which is why we multiply.
Okay.
You always multiply whatever's on the outside. If there was more than one thing left over, like say there was like an extra, like a 3 here, I'd also put the 3 on the inside. Anything that's left over stays on the inside, anything that's able to be pulled out, you're multiplied together. Yes, sir.
I use different multiples,
Yep.
and I got different answers than you.
Okay. You shouldn't.
Like,
Like 98, what'd you use?
I did 2 and 49.
Okay, so that should end up the same.
Yeah, I got that right. But I mean, for 6 and 32, I used 8 and 4.
Okay. Sounds fine.
And then I used 2. I erased what I had, so.
So you had 32, you said 8 and 4,
Yeah.
which this would be 4 and 2, which is 2 and 2, and this is also 2 and 2, correct?
Yeah.
Okay, so when you do this, you look, are there any pairs? Well, here's a pair of 2s. So on my outside, I already had a 6. There's a pair of 2s. Here's another pair of 2s, so I multiply by another 2. Here's what's left over, so this is what stays on the inside. So 6 times 2 is 12, times 2 is 24. You should still get 24.
Yeah, I did it wrong then.
Yes, ma'am.
On 15, when you got 16 before, why didn't you keep going 2 times 2? Because you can.
What I did is, there's another way of doing this where if you pick a perfect square, like 16 or 49, if you always pick the perfect square, you only have to go down one more step. Okay? If you use a perfect square. If these weren't perfect squares, I would keep going with these perfect. Yes, sir.
On number 11, where it says 32, and then 16, and then it went down to 4. Oh, why doesn't it break off in it?
I just answered that question less than 10 seconds ago. If you pick perfect squares, you only have to go down one more step, because if you break these down into 2 and 2 and 2 and 2, this 4 is just going to be a 2 times 2. It's the same thing, it's just making it a little bit shorter. That's why it's a really good idea to know your perfect squares, which is why I emphasized it a lot last week and then this week, is to know your perfect squares so that you can find multiples of them. Okay? Okay. Number 13, maybe you guys continued working on this without me, maybe you didn't, I'm not sure. Would you continue doing this? We break this down, this is 9 and 10. 9 is the perfect square of 3 and 3. You ask yourself, are there any pairs? Well, there's a pair of 3s. So there were 3 on the outside, there's now another 3. This square root of 10 is just a 5 and a 2, so we say 2 times 5 on the inside. So this is 9 times the square root of 10. 40 is going to work out very similarly. It's going to be 4 times 10, which is 2 and 2 and 2 and 5. There's a pair of 2s. So I say plus 4 times my pair of 2s. What's left over is a 2 and a 5, so it goes on the inside, they're multiplied together. 4 times 2 is 8, 2 times 5 is 10. Are the radicands the same? Yeah, they're both 10. So I say 9 plus 8 is 17 times the square root of 10. Okay, well, let's try number 14 for say you weren't here yesterday, how would you try number 14? 6 and 2.
Break down 6 and 3 and 2.
3 and 2, got it. Are there any pairs?
Yes,
2 and 2, so I'm going to take that on the outside with my 3. What's left over? A 3. How do we simplify this?
26.
Perfect, great. Great job. Okay. 9 and 3, got it. Are there any pairs? 3 and 3, so what do I have? Sounds great to me. Are the radicands the same? Yes, they are, so what do? Negative 18 times the square root. That is perfect. Very well said. Have you used all the correct language? Do you want to try the next one? Yes. Okay. Does anyone have any questions over 13 or 14? Okay. Please, go on the next one for us. You know. I like the way you picked the perfect square. Good job. Okay. Are there any pairs? Pair of 2. So I have 2. Sounds great to me. 63. 9, 7. Again, you picked the perfect square. Nice job with the 9. 3 and 3. Any pairs? Okay. Radicans are they the same? Yes, they are. So we just add them together. If we add them together. There we go. Great job. Is this okay? Can you handle this? Okay. So let's look at the bottom two then. All right. There's not much that's different. Here's all I want to do. If this 6 was not here, this negative 13 is not here. Let's just pretend those two are not there. Is this the same as what we did the step before? Yeah. Right. All we're going to do with those two are whole numbers. All we do, the proper way to write this is always have your whole numbers first, and then do the other stuff after that. Anything with a radical will come afterwards. It's kind of like when we would write things, we would write like 2x squared plus 4. We always write the x squareds first. Or we have like 6x minus 3. We always write the x's before the constants. There's a specific order that happens with radicals, is we write our constants like 14 first, and then we would say like 2 square root of 2. As opposed to seeing 2 square root of 2 plus 14. Generally speaking, we do not write it this way. We generally write them this way. With the whole number, the constant, whatever it is, first, and then the radical part second. Does that make sense? Now, if there's a third thing on here, like, like this, I don't know which one of these comes first. There's not really a rule for it. So what I say is just whatever order it started in, maybe end in that order, and honestly, if people have those flopped right, I can't really say it's wrong. There isn't really a rule for it. Okay? So here we go. We're going to ignore the 6 and the negative 13 till the end. So let's just break these guys down. This would be 9 and 2, which gives me 3 and 3. There's a pair of 3s. This is 2 times 3 times the square root of 2. Or 6 times the square root of 2. The 8 gets broken down into 2 and 4, which is 2 and 2. There's a pair of 2s that goes out here with my 4. And I have a square root of 2. So this becomes plus 8 square root of 2. And I'm just going to write in these other two numbers that I boxed at the top. This is 6 plus, this is minus 13. Right? So this is one way that I would just simplify the radical stuff, and then we'll look at the rest of this. Okay? I'll let people kind of catch up because I see a lot of people still writing. There isn't really a lot of room at the bottom, is there? I'm sorry. Okay. What we do is we worry about the constants first. So what's 6 minus 13? Negative 7, so we have negative 7. And then we look at the radicals. It's either radical 2. We say 6 plus 8 is 14, so we say plus 14 square root of 2. This becomes our final answer. So combine the radicals, combine the constants. That's all we do. Yes, sir.
The answer be wrong here.
Yeah, I was just discussing that. Generally speaking, we write the constants first, and then we write these next. I do want you to write it in standard form so that you can kind of get used to doing this. You'll see it in the future. You'll see it next year in AG2. If you take another math class after that, you'll also see this. They'll be written in this way. Try to write them in that way just to write it in standard form. Okay. Why don't you guys try the last one on your own? Try the last one on your own. It is the last one. It's the last one on our notes. When you have the last one, why don't you bring it up to me and I'll hand you your assignment. And we'll just have this do Monday.